I think so.
Did you watch them?
Yeah. Oh yeah, yeah.
Okay.
I check 'em. Yeah. I mean,
I don't know if I think
it's fine.
so, but
I mean, it's not like the best thing in the universe. I'm sure there are better quality videos, but I mean, as far as online videos go, they're okay.
yeah.
All right, folks. Let's go ahead and start by just reviewing the steps of this problem. Okay. I know we already did it, but let's see if we can create some steps. I'm going to start writing them down on the left-hand board. So step 1. What's the first thing that we do when we complete the square?
So you're doing 14.
Right. We know that what we want to do is turn this trinomial into a perfect square binomial, which means we need to have some sort of a goal in mind that we would take that middle term, which is negative 12, divided by 2, which is negative 6, and then square it, which is 36, and that's the number we wish were right there. Because if that was the number that was right there, we'd be able to rewrite it as a perfect square, and then square root both sides and solve. So we know that that's our goal. Our goal is that, boy, I wish that number was 36. So what do we do to accomplish that? We go ahead and move the 27 over. So move, I'm going to call it C to the right. Why do I call it C?
Because ABC.
Yeah, exactly, because we're looking at ax squared plus bx plus c. So we're going to move c to the right. So I go ahead and minus the 27 from both sides. And now that gives me a squared minus 12a equals negative 27. And you notice I left a little space. I'll even say that. Move c to the right, leave some space. Then what do we do? I'm going to add 36 to both sides, right?
Right.
And just to be formulaic about it, what is the number 36? The number 36 is b divided by 2 squared, right? So I'm going to write that down. I'm going to say add b over 2 squared to both sides. Is that fair that formulaically we would call it that? Is 36 really b over 2 squared? That's what we did, right? We took b, we divided it by 2, and then we squared it. So yeah, that's what we're going to add to both sides. We're going to add b halves squared to both sides. And in this particular case, we're going to add 36. All right. Then what? We can do 2 simple things to the left and the right-hand side. What'd you say? Yeah, so, yeah, like,
add those.
Sure, on this side, you can just add them. So 36 minus 27 is 9. Oops. And then what about the left-hand side? This is the fruition of our goal all along. We wanted to rewrite that trinomial as a perfect square binomial. So what is the perfect square binomial?
6.
Yeah, a minus 6 squared. And where did we get that minus 6 from? Yeah, that was the value of b over 2. That was the value of b over 2. That was the number that was being squared. All right, so we rewrite left as binomial squared. Well, I should just write it out. As a perfect square binomial. As a perfect square binomial. Now what do we do? It was square both sides, and we just solve. So at this point, this is basic algebra. This we could have done a long time ago. We square root both sides, which gives us, it cancels out the square and the square root, so we have a minus 6. This was an action step. We square rooted both sides. As an action step, it's plus or minus 3. So that's step 4, square root both sides, root both sides. And then when you do your last step and you add 6 to both sides, we're all going to remember to write our answer as the number, then the plus or minus number. We always write the number, then the plus or minus number. Why does the plus or minus number go second? Because in the quadratic formula, it goes negative b plus or minus the square root of b squared minus 4ac over 2a. In the formula, the plus or minus goes in the middle, so you have a number, and then plus or minus another number. So we prefer to have the plus or minus in the middle here so that this looks like the quadratic formula. I know that 6 plus or minus 3 doesn't look like the quadratic formula, but in fact, it is. Had we done this whole problem with a equals 1, b equals -12, and c equals 27, guess what the end would be? The end would be 12 plus or minus the square root of 36 over 2, which is 12 plus or minus 6 all over 2, which is 6 plus or minus 3. Oh my gosh, did you believe it? You might not have believed it when I first started. But the end of the quadratic formula is 6 plus or minus 3. So that's why we want to keep with that concept of doing 6 plus or minus 3. Okay, and then we will all...
Wait, so it's done? So like the answer to the question.
So now what I'd like you all to do is draw 2 little arrows. This is just me. But I do 6 plus 3, which is 9. And then I do 6 minus 3, which is 3. And those are my 2 answers. So root both sides, solve for x, and that's it. That's the process called completing the square. We haven't done the quadratic formula in class yet, have we?
No.
We haven't done any. Okay, so if that looked a little crazy what I just did there, that's okay. I just wanted to show you that using the formula, you really do get 6 plus or minus 3. And completing the square gives you the same result. All right, so now that we have done completing the square on that problem, let's go ahead and try it on the next one. So I'm going to erase all my work, but we'll keep the steps up on the board, and that way we can continue to observe how this process works. Now I'm going to do it right here. So let's all write down the original problem, which is z squared plus 12z plus 18. So what's our first step?
Divide by 2 to the middle.
Yeah, we can go ahead and do that step now if we like. We can go ahead and say, okay, that's 12 divided by 2, which is 6, and then 6 squared is 36, and 36 is the number I wish that I was adding by at the end. But according to our steps, what's the first step?
Move C to the right.
Yeah, we go ahead and move that c term to the right, so I'm going to move my 18 over. So now I have z squared plus 12z, leave some space, equals -18. And now I know what number I want to add in. I'm going to add b half squared to both sides. And my b half squared value is 36. So I'll go ahead and add that in to both sides, add 36. Our third step was just to clean that up, rewrite the left-hand side as a perfect square binomial, do the addition on the right-hand side. So what is my perfect square binomial? Yeah, z plus 6, because 6 was that special number up at the top. That was b halves. Your number is b halves. That's what goes in there. All right, and then what? You square root both sides, which cancels the square on the left, so I have z plus 6 equals root 18. Well, what is root 18? It doesn't come out clean.
9 plus 2.
It's 9 and 2, so if I were to simplify that, root 18 is really root 9 times root 2, which is really 3 root 2. So now I have 3 root 2. And then we subtract, oh, that's plus or minus. It's always plus or minus because the root I did was an action step. So I subtract 6 from both sides, and we write this -6 first, plus or minus 3 root 2. Now in this case, can we add -6 plus 3 root 2? Can we subtract -6 minus 3 root 2? No, because they're not like terms. We can't actually add -6 plus 3 root 2. You can write out the 2 separate answers if you wanted to. You can say it's -6 plus 3 root 2. That's one answer. And -6 minus 3 root 2. That's another answer. But since you can't combine those, what's the best you can do? The best you can do is get a decimal. That's the best. Oh, and I didn't bring my calculator. Right. So let's get a decimal so we can visualize what this looks like. So root 2 times 3 minus 6. So first one's at negative 1.757. And then the next one was root 2 times 3. And I got negative 10.24. Is that what the recipe got on your calculator? Did I do that calculation correctly? Did the recipe get that? Okay.
Yeah.
Now, the $1,000,000 question. What do those two numbers represent? What's that? That's it? Yeah, that's the value of z. Yeah, and what can I do with those two numbers? I can plug it in and make that equation true, right? So if I plug either of those numbers into this equation, the equation will be true. I don't think any of us want to plug those two numbers in, but if we did, it would make the equation true. What else do those two numbers represent, other than the fact that they're the two numbers you can plug in to make it true? They're the what? Yeah, they are the x-intercepts. So everybody draw a graph. Find the x-intercept of negative 1.7 and the x-intercept of negative 10.2. And do you see the parabola? Do you see the parabola cutting down below the x-axis and then going back up again? Your parabola would be this. That is the actual graph of that parabola. So yes, negative 1.7 and negative 10.2, they're the two numbers you can plug into that equation to make it true. And they're also the x-intercepts of the parabola. So now we know what the graph looks like.
So kind of like, is it any different if we just write it down like plus c equals plus or minus 3 square root of 2 minus 6?
We don't want to write it down that way. You could write it down as plus or minus 3 root 2 minus 6. But there's two reasons why we don't want to do it that way. What's one reason?
Oh, it's hard to tell what's underneath the root sign then.
Yeah, that's one thing. It's hard to tell what's underneath the root sign. Is it really root 2 and then end of the root and then minus 6? Or is that root going all the way over? In which case I would say, well, 2 minus 6 is negative 4. And then I'd have plus or minus 3 of negative 4, which is imaginary. And then that would be plus or minus 3 2i, which would be plus or minus 6i. And so you get all carried away because you're not quite sure where the calculation ends. So that's one reason not to put the minus 6 at the end. What's the other reason?
Because you told us not to.
I told you not to. That's the third reason. What's the second reason? The most important reason.
Oh, so
Yeah.
it matches the little.
So it matches the quadratic formula. And as I said, look, the quadratic formula actually has a square root. That's the 3 root 2 term right there. That's the root 2 term. In fact, that was the root 18. That was the plus or minus 18 right there. So you're supposed to put the number and then the plus or minus and then the root. So we don't want to do this. We want to have a number plus or minus a root number. And because that's exactly what the quadratic formula is. Okay, thank you, Azeb, for that question. All right. Let's go and try this next one. This next one is a little more exciting. I can tell already that you're all pretty excited about this one. P squared plus 3p minus 9. And why are all of you so excited about this problem? What do you notice about p squared plus 3p minus 9? Right, you can't divide 3 by 2. I mean, you can. 3 divided by 2 is 1.5, or it's 3 halves. But the point is the middle number is not even. And we're probably all sad about that. So, oh no, it's not an even number. How am I going to divide by 2? Well, let's just try it. How would we divide by 2? I take the middle term, I divide it by 2. That's 3 halves. We're going to write it all as fractions. We're not going to do decimals like 1.5. What, Olivia?
That's what I did, but I can't finish it.
What? Oh, with the fractions?
Yeah.
Okay, good. I'm glad you did the fractions. And why are we going to use fractions and not decimals? Because the quadratic formula is one big fraction. And so we want to stick with fractions, not decimals. Okay, so we take our 3 divided by 2, then we square it. And what does that give us?
9/4.
9/4. That's the number that we wish were right there. Olivia? Yeah, not -9. So what do? Step 1.
Move C to the right.
Move C to the right, so we add the 9 over, get it out of the way. So we have p squared plus 3p space 9. And what do we wish that number had been? 9/4. So we add 9/4 to both sides.
Is it still plus or minus?
Nothing is plus or minus yet because we haven't square rooted anything.
Oh,
Yeah, really good question. All right, so we move C to the right, we added b half squared to both sides. Now we rewrite the left as a perfect square and we rewrite the right-hand side. So on the left-hand side, what was our number being squared? Because remember, that's always the number that goes inside, 3/2. So this is p plus 3/2 squared. And what is 9 plus 9/4? We could find a common denominator. This is really 9 over 1, and the common denominator is 4. So we multiply 4 on top and bottom. That'd be 36/4 plus 9/4. And 36/4 plus 9/4 is 45/4. I did a bit of that in my head. You really want to take your time and do that fraction work correctly. Maybe you come over here and say, okay, 9 plus 9/4. That's 9 over 1. I multiply top and bottom by 4. That's 36/4 plus 9/4. And then I add them together. That's 45/4. Okay, I'm convinced. It's 45/4. All right, next step. Square root both sides. So we square root both sides. That cancels out the root. I'm sorry, the square on the left. We have p plus 3/2 equals, well, how do we square root a fraction? You do the top and the bottom separately. So the root of the top is just root 45. The root of the bottom, root 4, is 2. So you square root them both separately. But what is square root 45? Can we simplify that? Yeah, 45 is really 9 times 5, which is really 3 root 5. So it is possible to simplify that. So, oh, and I should have been putting my plus or minuses already. There's my plus or minuses. So this is really p plus 3/2 equals plus or minus 3 root 5 over 2. And then what? We subtract the 3/2 over. And we end up with p equals negative 3/2 plus or minus 3 root 5 over 2. Now what do you notice about the final fractions?
The same.
They have the same denominator. So couldn't we go ahead and add them together? Since they have a common denominator, you can rewrite it now as negative 3 plus or minus 3 root 5 all over 2. And what does that look like?
The quadratic.
It looks like the quadratic formula. You have a number plus or minus a root term all over 2. So this is why we keep our answer looking like this, so that it looks as consistent as possible with when we start doing the quadratic formula. Now, of course, you know what I think we should do right now.
We should find out what the real answer is.
We should do the quadratic formula and see if we get the same thing. Yeah, is that what you meant?
Oh, I was going to give a decimal answer, but
Oh, well, yeah. We could go ahead and do a decimal, and we should do a decimal because we need to know what the decimal approximation is. But, you know, you just type that into your calculator and you get it. So on the right-hand side, folks, should we try the quadratic formula once? I think we should give it a shot. So everybody start by writing down the formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And what are we going to do next? You're going to write it again, but you're going to write it empty. Did I mention that before, writing it empty? How do we write it empty? We replace every letter with an open parenthesis. So we say negative b plus or minus the square root of b squared. Every time I say a letter, I just put open parentheses. minus 4ac, I'm just putting parentheses every time I say a letter, all over 2a. That's called writing it empty. You write it empty so that you're going to be super careful with your positives, your negatives, and your multiplication. So now I just drop in all my numbers. What are our numbers? Our numbers, I should jot them down, are a is 1, b is 3, and c is negative 9. So those are the numbers we're going to plug in. So let's plug them in. Negative b plus or minus the square root of b squared minus 4ac. See, that was the very careful part, the fact that that's a negative 9 all over 2a. So we all plugged in 3, 3, 1, negative 9, and 1. So now we can start cleaning all that up. The first term is just negative 3 plus or minus the square root of 9. And then we have a negative 4 times a negative 9. And what's a negative times a negative? Positive 36 all over 2. And now what do we have? Negative 3 plus or minus the square root of 45 all over 2. And that's already the same answer, right? We recognize it. Negative 3 plus or minus root 45 over 2. And what is root 45 if we simplify it?
3 square root 5.
Yeah, 3 root 5. So did we get the same answer?
Yes.
Yeah, we did. Which way did you like better? What's that, Olivia? You like the plug it in method of the quadratic formula?
Yeah.
Yeah, it's not bad, right? You plug it in and you just have to be very careful about your positives and your negatives and how you do all of your arithmetic. We will practice both methods and you'll be tested on both methods. Like on the test, it'll say, solve this quadratic equation using completing the square. And then solve this quadratic equation using the quadratic formula. Okie doke. So if we did go ahead and find the decimal values, which I don't know what they are, but whatever they would be, that would be the x-intercepts, and you'd draw your parabola going through them. Okie doke. Let's try another one. Now, admittedly, that one was tricky. Why was it tricky? Yeah, because of the fractions, because that middle term is an odd number. Okay, I'm gonna slice all this. How else could a problem be tricky other than the middle number being odd?
Could be like a square root. Could be.
Yeah, I mean, oh, geez, it could be a lot of different things, right? It could be a decimal, it could be a square root. In this particular case, the problem is 4r squared plus 24 equals negative 19. So already, what's the first thing we know we have to do? We need to put it in standard form. Well, although, I mean, we should put it in standard form, you know, bring the 19 back over to the left. Although I guess maybe we don't really have to do that because what are we going to do to our C term? We're going to move it over there. So maybe this is actually more convenient. They already have the C term on the right. However, the process we've been talking about has only been for when x squared has a 1 on it. So we haven't dealt with this problem of the x squared having a number on it. Remember when we were doing factoring, if there was a number up front, you had to do something special? Well, what can we do right now to make it not have a number on the r squared? Do what? Take it out? How do you take it out? We could just divide everything by 4, right? Would that work? Could we divide everything by 4? I don't see why not. Then we'd have r squared plus 6r, leave some space, equals negative 19/4. And in fact, if we really wanted to be nice to ourselves, we could always change 19/4 to a decimal. And then that would only be what? Negative
4.75.
negative 4.75.
4.75.
Yeah. But later on, we're going to have to go back to decimals. I mean, back to fractions anyway. So let's just leave it. Let's go ahead and complete the square right now. How do we complete the square? We already moved c term to the right. Now we have to add half of b squared to both sides. So half of 6 is 3, and 3 squared is 9. So that's what we add to both sides, plus 9. plus 9. So we added b half squares to both sides. Now we rewrite the left, and we rewrite the right. So on the left-hand side, what's our perfect square binomial? R what?
9.
Yeah, r plus 3. Technically, this number is always b halves, right? It's just the number after you've divided it by 2. Then on the right-hand side, oh, we need to find a common denominator again. So I'm going to go somewhere else, write negative 19 fourths plus 9 over 1. I need a common denominator, which is 4. So now I have negative 19 fourths plus 36 fourths. And when I subtract 36 minus 19, what does that give me? Is it 17 fourths? Not the most friendly of fractions, but, you know, it's the answer, 17 fourths. I'd like you to notice that we've done most of the heavy lifting already. Most of the hard work of the problem is done. Because what do we do now? We just square root both sides and we're practically done. So now we have r plus 3 equals, again, how do you square root a fraction? Top and bottom, so that's root 17 over 2 plus or minus. So we have our root, our plus or minus root 17 over 2. And so r is being added by 3, so we subtract by 3. And it's negative 3 plus or minus root 17 halves.
They probably have a different answer.
What do they have? They do have a different answer. Is it really different?
Well, there's a big difference between 3 and 6.
There is a big difference between 3 and 6.
Oh, they divided, no?
Well, you'll notice their answer is one big fraction.
Okay.
We have a number in front. If we wanted to add these two fractions together, what would you need? You need a common denominator. So you multiply the top and bottom by 2, right? And so then you would have negative 6 over 2 plus or minus root 17 over 2, which allows you to then you just make it one big fraction all over 2, which is negative 6 plus or minus root 17 all over 2. Maria, that was your answer, right?
That was what the back said, yeah.
Yeah. Now, folks, they're both perfectly fine answers. If you just kept negative 3 plus or minus root 17 over 2, that's fine. If you make it look like negative 6 plus or minus root 17 over 2, that's fine. Which one of those is what the quadratic formula is going to tell you?
The second one.
Yeah, the second one. The second one is the quadratic formula. In case, in fact, if you wanted to see it real quick, that's 4r squared plus 24r plus 19 if I move everything to the left. So then A is 4, B is 24, C is 19. Whoa, those numbers are pretty big. So the quadratic formula would be negative B plus or minus the square root of B squared minus 4AC. Oh, those numbers are very big. All over 2A. So it'd be negative 24 plus or minus the square root. I don't claim to know. What, 24?
576.
What?
Isn't it 526?
Oh, it is 576. Minus 16 times 19, which is 304, all over 8. And so then that's negative 24 plus or minus 2, the square root of 272, all over 8. And then we would have to simplify the root 272. I'm guessing it's divisible by 17. Yeah, it is. Root 272 is really root 16 times 17, which is root 16 times root 17, which is 4 root 17. And so now we have negative 24 plus or minus 4 root 17 over 8. Does our answer look like theirs yet? Maria?
I have a question. Why did you get negative 6 over 2?
Because I took negative 3 over 1 and I changed it to a common denominator of a 2.
Oh.
Yeah, good question. So what do I have to do now with the 24, the 4, and the 8?
Divide.
Yeah, those are all simplifiable. They're all divisible by 4. So 4 goes into 24 6 times, 4 goes into 4 once, 4 goes into 8 twice. And now I have negative 6 plus or minus root 17 all over 2, which is the answer they have. Folks, you notice this is a lot of just arithmetic. It's a lot of arithmetic. In fact, did we do any algebra? Well, not in this. In the quadratic formula, we don't do any algebra at all. It's just pure arithmetic. You're just multiplying, subtracting, dividing, adding. In this case, we are rearranging things, and in fact, we are doing algebra. So that's an interesting difference between these two methods. In completing the square, you're doing algebra. In the quadratic formula, you're doing arithmetic. Nope. All right. Folks, I tell you what. I think 18 is slightly more than what we really genuinely have to do in this class. Because I want to make sure that we have enough time to get through to everything else that we want to do. And let's see, those have complex solutions. Ooh, that one's going to be good. And then we get to the quadratic formula. Let's just, everyone, we can agree to skip 18. Now, I'm telling you that we can skip 18. Does anyone want to see 18? Because we could still do it. It's just that no one would actually do completing the square with that one. Why would no one actually do completing the square with that one? Yeah, because there's a 7 and a 3. It's terrible. I just want a demo for you. So like, if you had 7x squared plus 3x minus 4, well, you'd first have to move the 4 over, and then you'd have 7x squared plus 3x equals 4. But you can't have the 7 on the x squared. You need to get rid of it. So you divide everything by 7. And now you have this terrible situation of x squared plus 3/7 x equals 4/7. And at that point, you'd have to begin the process of completing the square. So how does completing the square work? You'd have to take half of the middle term and square it. What's half of 3/7? What's 1/2 times 3/7? 3/14. And then you'd have to square it. And that'd be 9 over 196. And then you'd have to, that's the number to add to both sides. So you add 9 over 196 plus 9 over 196. And now you're ready to, this is your middle term. So that's really x plus 3/14 squared equals whatever that is. And what do you have to multiply by 7 to get that? I think it's 28 on top and bottom. So you then multiply by 28 on top and bottom, then you get 100, that's really 112.96 plus 996. And so then you'd have 121.96. Anyway, you can see that it's just, it becomes a brutal process. Why is it brutal? All the fractions, it's just a lot of fraction work. And we're not even done yet. I would still have to square root both sides. Oh, actually, that was 196. What did I do wrong? That was 196. So then when I square both sides, I have x plus 3/14 equals plus or minus. Oh, actually, that turned out, didn't it? The square root of 121 is 11, and the square root of 196 is 14. So now I have x plus 3/14 and plus or minus 11. I subtract 3/14. Then I end up with x equals negative 3/14 plus or minus 11/14, which is negative 3 plus 11 over 14 and negative 3 minus 11 over 14, which is 8/14 or 4/7, or negative 14/4, which is negative 1. Okay, I know I sat there and I said, let's not do this one. And what I really meant was, you guys don't worry about doing this one. But I wanted to show you anyway that you could in fact do it. But what do you have to do in order to do a problem like this?
Use that.
Lots and lots and lots of fractions. Lots and lots and lots of fractions all the way to finally get those two answers. Whereas what a normal person would do, if they wanted to solve this problem, they would say a equals 7, b equals 3, and c equals negative 4, and they would just plug it into the quadratic formula and get their answer. Because remarkably, when you do the quadratic formula, do you ever deal with fractions? No, in fact, every part of your computational process is whole numbers times whole numbers. The final result is a fraction, but you're not actually computing a bunch of fractions, whereas in completing the square you are. Okay, so did everyone cross out number 18? Yes. Okay.
Yeah.
What's that? Yeah, all right, so the next two problems, we're still going to do completing the square, but notice what the instructions say. What do the instructions say? Yeah, find the complex solutions. Folks, what does complex mean? Is that just because everything we've been doing has been mighty complex? What actually does complex mean? I don't think we've said yet. Okay, so here's the definition. First of all, the word imaginary refers to the square root of -1, which is I. So we use the word imaginary to refer to the square root of -1. Because you can't actually do it on your calculator. We're just pretending like it's a real mathematical object, and we just act like it is. So the word complex we use to refer to any number of the form a plus bi, such as 2 plus 3i, or 4 minus 5i, or -6 plus 7i. So a complex number has a real and an imaginary part. We call A the real part, and we call B the imaginary part. And that's what we call a complex number. It's complex because it's a little bit of both. A complex number has a real component and an imaginary component. And we actually saw that the other day. The other day, didn't we multiply 4 plus 3i times 4 minus 3i? I thought we did.
Yeah.
And we noticed something quite remarkable. That, okay, so 4 plus 3i, that's a complex number. 4 minus 3i, that's a complex number. And when we actually FOIL those together, remember this is a conjugate. These are conjugates, one's plus, one's minus. We got 4 squared minus 3i squared, which is 16 minus 9i squared. And what's I squared? What does I squared equal to? -1. I squared is -1. And we ended up with simply a real number. 16 plus 9 is 25. So you can actually multiply a complex number times another complex number and just get a pure real number. So right about now, we can we can distinguish between our use of the word real and imaginary. When we use the word real, we're talking about a number that you find on the number line. When we say imaginary, we're talking about 5i, 6i, -3i, some number with an I on it. Okay, so all that said, when it says find the complex solutions of the given equation, what does that tell us the answer is going to be? The answer will be partially imaginary. Some part of the answer will have an I in it. There will be an I in it. Now, what does that mean in terms of the parabola? Where is this parabola? If the answers are two imaginary answers, where is the parabola located? Remember we talked about the parabola being this word. So there we go. Where is this parabola? It's floating above the x-axis. It doesn't actually touch the x-axis. Remember, you can either have a parabola that touches the x-axis twice, like this one touches it twice. You can have an x-axis that just barely touches it, like there. Oh geez. Oh, that's too much. Oh no, it's not enough. Ah, there we go. Like this parabola just barely touches the axis once, whereas our parabola doesn't touch it at all. So let's remind ourselves, what an imaginary solution even means. In fact, I think everybody should go ahead and write this one more time. When you're solving a parabola, it either goes through the x-axis twice, and that means there are two real solutions, or the parabola could touch the x-axis once. Yeah, I could touch it once and have one real solution. Or the parabola could just be floating up above, and that means you have two imaginary / complex solutions. So that's what we're considering. Every question we've asked so far is, where's the parabola? Where's the parabola? And so this one, they're setting us up to know that this parabola is going to be floating above the axis. So the answers are not real, they're imaginary and complex. Okay. Well, folks, let's do it. We're going to complete the square. What are the steps? Jeff, what's the first step?
Move the C term to the right. So
Yeah, let's move that C term out of there. So we have x squared plus 1x equals -2. Everybody leave a little space. And what's our second step? Maria? Over here, Maria. What's our second step? Yeah, add b halves squared. Yeah, b halves squared. So we're going to take b, which is 1. So we take 1, we divide it by 2, that's just a half. And then we square it, and what's 1/2 squared? 1/4. Because 1/2 times 1/2 is 1 times 1 on the top and 2 times 2 on the bottom. So we're going to add 1/4 to both sides. So we add 1/4 to both sides. And what was our third step? Ours?
Square both sides.
We're now ready to square root both sides.
Oh. Oh, you have to write it as a perfect square line.
Yeah, we're going to rewrite this left-hand side. So it's x what? X what squared? Yeah, the 1/2. Always that number that's being squared. The number that's being squared is the number that goes inside the binomial. So it's x plus 1/2 squared equals, what's -2 plus 1/4? Again, you might have to go somewhere else and do a little fraction work. -2 plus 1/4, we need a common denominator of 4. So we multiply top and bottom by 4. That's -8/4 plus 1/4, which is?
7/4.
Yeah, -7/4. Now you can probably see right now why the answers are going to be imaginary. Because what are we about to do? We're about to square root both sides. And on the left-hand side, that's fine. We can square root the left-hand side, no problem. It just cancels out the root. But on the right-hand side, we just square rooted a negative, which makes it imaginary. So now we square root the top, we square root the bottom, put in our plus or minus. And so far we have that it's x plus 1/2 equals the plus or minus root -7/2. What do we do with the square root of a negative?
Pull out the I.
Yeah, we just pull out the I. So this is really x plus 1/2 equals plus or minus I root 7 all over 2. Remember from the other day that when you have the square root of a negative number, you can just pull that negative out as an I, and you keep the same number underneath the square root. It's just now the I is out front as opposed to a negative on the inside. All right, and the last step is we solve for x. So we subtract 1/2 from both sides. And we have x equals -1/2 plus or minus I root 7 all over 2. And the fact that yeah, go ahead, Alex.
Combine them.
You certainly can. I was about to say, so long as you have the common denominator, if you want to make a common denominator, you can just say the answer is -1 plus or minus I root 7 all over 2. And I bet that's the answer in the back. 19?
They got this one separated out, probably because of the I, I'm assuming.
Oh, it could be. Maybe they wrote the answer as,
And they always put the I afterwards.
they're putting the I afterwards because it can unambiguously go after the fraction and you won't think that the I is underneath the square root. Is that what they said?
Yeah.
Yeah. So that's just another way to show the answer. So what does that mean anyway? The answer is imaginary. So what does that tell you about the parabola? It's floating up above the axis. It doesn't touch the x-axis. And nevertheless, if you took that number and plugged it into the original equation, it would actually make the original equation true. Okay. Last, completing the square problem. We have 6m squared minus 9m plus 5. This would be a fair problem for me to put on the test. What do we do?
We do it the other way.
Well, the thing is on the test I'm going to say do completing the square, not quadratic formula. But you could do the quadratic formula to check your answer. So what do? Of course we have to move c to the right, but there's one other thing we have to take care of.
You remember that 6.
We have to get rid of that 6. So we can do it first. You can go ahead and divide everything by 6. So we'd have m squared minus 3 halves m plus 5 6. Oh, you know what? I wouldn't give you this problem on the test. Because now what would we have to do? We're going to have to subtract 5 6. And so then you have m squared minus 3 halves m. Leave a space equals negative 5 6. I mean, I suppose I could.
You have
And then
to
you have to,
divide it by 2.
Yeah, so we take negative 3 halves, and we divide it by 2, which means multiply it by 1/2. And that gives us negative 3/4. And then we do what to it? Square it, and that gives us 9/16. And that's the number we add to both sides. So plus 9/16 and plus 9/16. Oh, well actually this isn't bad. Oh wait. Yeah, no, this isn't bad. Let's finish the problem. This is a really good problem. So now, how do we rewrite it as a perfect square binomial on the left? It's m what?
Minus 3. Oh.
Yeah, the number being squared. So it's m minus 3/4. And over on this side, can you do 5 6 and 9/16? You need a common denominator, don't you? And what's the common denominator for 6 and 16? I think it's 48. Now, how did I know that? Because I'm not like a super genius. 6 is 2 times 3,
28.
and 16 is 2 times 2 times 2 times 2. And so they need to have the same factors. So I'd have to give this one a 3, and I'd have to give this one 3 more 2s. And that's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3 is 48. So the common denominator is 48. So we would have to multiply this one top and bottom by 3, and this one top and bottom by 8. So that's negative 40 48ths plus 27 48ths, which is what? Negative 13 48ths? Did I do all of that correctly? And so that's our fraction over here. Super easy, straightforward, there we go. All right, now we're ready to do what? Yeah, square root, say root. Yeah, there you go. Square root both sides, that cancels it out. M minus 3/4 equals the square root of all that. Now, that'd be the square root of negative 13 on top and the square root of 48 on bottom. This is like the mother of all problems because we're doing everything. We're doing things with fractions. We had to find a common denominator over there, a fairly good one. And we have to simplify root 48. What is the simplification of root 48? What square number goes into 48? We already know. What square number goes into 48? Because this is 48. So what square number goes into it? 4. What square number?
4.
16.
Right.
Yeah. So it's going to be, but yeah, I mean, you're both saying the right thing. So that's really 16 times 3, which is root 16 root 3, which is really 4 root 3. Well, I just lumber out of room. I'm coming up here. So I have n minus 3/4 equals plus or minus I root 13 all over, what is it? 4 root 3.
Did you have to get rid of the roots on the bottom?
You have to get rid of the root on the bottom. Remember rationalizing the denominator? We're not allowed to leave a root down there. So we would multiply top and bottom by root 3. So now we have n minus 3/4 equals plus or minus I root 39 all over 4 times 3 is 12. Oh boy.
Don't you have to multiply the other side by 2?
Just the top and
Oh,
bottom.
no. Okay.
Yeah, just the top and bottom of that side. But we finally have a nice simplified expression. A nice simplified expression on the right. And so now we can finally add our 3/4 over. And we have m equals 3/4 plus or minus I root 39 all over 12. What's the last thing we could do with that? Yeah, you want to find a common denominator, which is 12. So multiply top and bottom by 3. And we have m equals 9 plus or minus I root 39 all over 12.
And they stopped a step back, which is weird.
Oh, did they really? They stopped at 30. Oh, that's fine. They could have also stopped at 3/4 plus or minus root 39/12 I.
Yeah.
Yep. You can represent an answer in a lot of different ways. The reason they represented it here as 3/4 plus or minus root 39/12 I is because they wanted to make it look like A plus B I. Because that's the definition of a complex number. A complex number is a real number plus an imaginary number. And so they wrote it down like that. Because then you can look at it and say A is 3/4, B is root 39/12. Folks, that was a really good problem. You know, on the last test, there was a, what problem was it? Oh, it was solving a problem with 2 square roots, and it took a lot of work for everybody. I mean, this would be like the super good problem to put on this upcoming test. Because it requires so much mathematics.
You could just put the one problem on the test.
Just the one problem? You're fun. Hey, Maria. I could.
That would be awesome.
I could, but that would be imaginary. All right. Well, nicely done, folks. That's it for completing the square. That is, that's it for us practicing it right now as a group. Yeah, so now we're going to go ahead and take a look at the quadratic formula. And we'll practice it a few times, and then you'll be able to say for yourself which you like better, the quadratic formula or completing the square. Alex, you already know it? You already know that you want to do completing the square. You know, also, folks, the nice thing about completing the square, the nice thing about the quadratic formula, it always works. It works with anything. Whereas completing the square, sometimes it's convenient and sometimes it's not. I mean, definitely completing the square on this problem took more effort than just doing the quadratic formula. But see, sometimes completing the square takes less effort than doing the quadratic formula. All right. Everybody ready? So what is the quadratic formula? Do you have it memorized yet?
Yeah.
Maybe you do, maybe you don't.
B plus and minus.
So the only way I've ever heard it sung, so given ax squared plus bx plus c equals 0, x equals. I have heard it to the song of Pop Goes the Weasel. Does anyone even remember that song?
All around.
Yeah, keep going, Maria. Sing the
No,
whole song
that's
to
okay.
us. I don't even know the lyrics. All
Around the mulberry bush, the monkey chased the weasel. Monkey thought it was all in fun. Pop goes the weasel.
Do you guys remember that song?
I know all the verses. Just
You do?
Yes.
Well, I don't know any of the lyrics, but here's how I've heard it. So it goes x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Isn't that adorable? It's just adorable. So whatever you have to do, folks,
Okay.
to get that thing memorized, you need to have it memorized.
Negative B
Plus or minus square root of b squared minus 4ac all over 2a.
It's still hard to remember even with the song.
Yeah. So ultimately, though, what you really need to do, you need to write it down over and over and over and over. There's nothing more sad for me than when someone's taking a test and they write down the formula first and they say negative b plus or minus the square root of b squared minus 4c all over 2. Because then they do the whole problem and they're doing the whole problem all the way to the end, but they did the whole thing wrong because they forgot the formula. So you want to write it down so many times that you memorize it. You can even make little jokes about it. Like a B is a negative thing because it stings you and it hurts. It's a negative B. And then 2A, maybe you're like Canadian. 2A, I don't know. You just got to make things up until you memorize it, folks. All right. Should we just take our break before we start this? We might as well. Let the brain cool down for a moment.
Claudia, Jeffrey, Olivia, no Karina, Zeb, Amy, no David, Maria, no Layla, no Ayan, Anna, Alex, and What's that?
This time I don't want to get anything
You what?
because my grade is getting way lower.
Oh, and you asked me to look at it?
Yeah.
Hmm.
Is that-
Well. Hmm. Mm. Well, I tell you what, Azeb, all of this looks good.
Okay.
There's one thing missing from number 3,
Okay.
which you did on all the other problems, but
Okay.
you didn't do it here.
Okay.
And then otherwise, how can you check
I
that
know
your
what.
answers are
I
correct?
know what.
Oh, well, how can you check your answers?
Plug it in back.
And you could use your calculator to do that.
Okay.
This is pretty terrible to do without a calculator.
I don't think that the beginning salary is going to be worth that. So. So, yeah. Ask some of the ladies with older kids. They'll tell you all about it.
All right, folks. Let's get started.
Anyway, there's a lot of things to consider.
All right. We want to now, instead of doing completing the square, we want to use the quadratic formula. So what should be the first thing we do? We know we're going to take the coefficients from that formula and plug them in over there. What would be a good best practice? For instance, what's the number in front of a squared? 1. We should write it in there because we need to visually be able to reference it later. And in fact, what would be even more helpful? Not just seeing the numbers. I suppose you could just write A, B, C right there, and that'd be helpful. But the most helpful thing you can do is actually write down A equals 1, B equals 2, and C equals negative 24. Because that forces you to make a very conscious, aware choice of what those numbers are, especially the negative 24. It would be terrible to go through the whole problem using positive 24 instead of negative 24 and getting the wrong answer. So that's one best practice, is actually write out your values for A, B, and C. The next best practice is to not only write down the actual formula, negative b plus or minus the square root of b squared minus 4ac, all over 2a. So you write down the formula, and then you write it empty. You say negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you'll notice the way I wrote it empty, I put it exactly below the formula. It's not shifted to the right or left. I didn't write it more narrow or more wide. I made an identical copy of the formula below the other formula. And why did I do that? Yeah, so that I can clearly see, like it's right below it. I can sit there and point and go along with it. I can say, okay, B, oh, there's B, it's right below it. I'm going to drop down and put it in 2. And then now that's B, right below it, I'll drop it down and put it 2. And now that's A, drop right down below it, that's a 1. And now that's C, drop right down, that's a negative 24. And then that was an A, drop straight down, put in a 1. What? Okay. So very helpful to put the formula directly above so that visually your eyeballs can float up and down and see exactly what numbers you're putting in. Then what? Then you go ahead and you start simplifying certain things. Like I always find it very helpful. I do 3 things first. I rewrite the first term, so that's negative 2. I square and multiply the numbers, but I don't add them together yet. So 2 squared is 4, and negative times negative is positive, 4 times 24 is 96. That's all I do. I write down the first number, I square, I multiply, I write down the bottom number. I'm not trying to do the whole darn thing in one step. I don't want to do anything in my head. That is, had I added the 4 plus the 96 right then to get 100, I'd have been risking making a mistake. So now I'll move forward, continue to write negative 2 plus or minus. Now I write down the square root, which is simply 100 over 2. And again, I realize you probably could have said, oh, 4 plus 96, that's 100. I'll just go ahead and square root it. But I like to just do one thing at a time. So now I have negative 2 plus or minus 10 all over 2. Now I realize that right here you could cross cancel. You could simplify, I'll divide all of those by 2. But I'm not going to do that. I'm just going to draw a little arrow, draw my 2 arrows. The top possibility is negative 2 plus 10 over 2. And the bottom possibility is negative 2 minus 10 over 2. So that gives me 8 over 2, which is 4. And that gives me negative 12 over 2, which is negative 6. I realize I could have skipped a lot of steps for this. I could have, and you could have too. It's very possible to not even write the numbers A, B, C, not even write the formula, and you could just stare at it and say negative b plus or minus the square root of b squared minus 4ac all over 2a. I probably could have skipped all the way to there, but do you know how dangerous that is? You could hurt yourself skipping all those steps. You don't want to do that. And then I probably could have gone, well, 4 plus 96 is 100, square root of 110. Then I can say, oh, 2, 10, and 2, that's actually 1, 5, and 1. And I could, again, you could be skipping all sorts of steps, but I think it's so dangerous. And then you can say negative 1 plus 5 is 4, negative 1 minus 5 is negative 6. You could do the whole problem right there. If you did that, not only wouldn't I give you full credit, I'd take off more credit than the problem's worth. Just for the sheer audacity of what you're trying to do. So please show all of your work. That's dangerous. Ooh. It's like a horror movie on Halloween. That's how scary that was. All right, well, we're all done with that first one. Everybody's excited to try the second one? Or are we still writing down the first one? I don't want to rush anybody. So we have quite a few quadratic formula problems ahead of us. Just in terms of practice, there's 22, 23, 24, 25, 26, and that's it. So there's 5 more. I don't want to do all 5 with you because I need to leave some of them for homework. So which one should we do? Does anyone have any preferences? I don't think we need to do 22 because that looks pretty straightforward. We could look at 23, 24. I don't think we really need to see 20. How about we do, I think 23 and 24. 23 and 24 would be 2 good model problems to consider. I'm going to bring this down, and we'll take a look at those. In general, before beginning the quadratic formula, what do you need? Like right now, this is 4n squared equals negative 10n minus 2. What do I need to do first? One right hand? You pointed at it. What do I need to do? Yeah, it has to all equal 0, right? Because the formula refers to ax squared plus bx plus c equals 0. So you need all the terms on the left. So this negative 10n, we need to add 10n to both sides. And the negative 2, we need to add 2 to both sides. And that way we have 4n squared plus 10n plus 2 equals 0. So first and foremost, you have to write it in standard form. So I'll make a note. Note. Always write in standard form. Of course, that's true for completing the square as well. You need to have it in standard form. Ax squared plus bx plus c. Okay, and then we had 2 best practices. What was the first best practice? What was the first best practice? Before I start writing the quadratic formula, what should I do? Write down what the values are for A, B, and C. Write them down, C to Cn. A is 4, B is 10, C is 2. That was the first best practice. The next best practice is to write down the formula once. Negative b plus minus square root of b squared minus 4c all over 2. And then you write it again, but yeah, empty. You write it with all those parentheses. Negative parenthesis plus or minus square root parenthesis squared minus 4 parenthesis all over 2 parentheses. No, I'm just kidding. Don't say it with parentheses. It'd be the worst. And now we're ready to start the problem. Again, I know a lot of people wouldn't do that. They would just start writing numbers down. But I really hope you don't do that. I really hope you write down A equals B equals C equals, write down the formula, write it empty, and then plug in all of your features. So B is 10, B is 10, A is 4, C is 12, A is 4. And then you just start baby stepping your way towards the solution.
Realize it.
That's
That's
two.
Oh, C is 2. Thank you so much. I was checking to see if everyone was paying attention, and you did. All right, so again, I only do a couple things at a time. Whoops. I would rewrite my -10, rewrite 100 minus 32 all over 8. Then I'll just subtract. What is that, 68? Is that what everyone else got, 68? Well, 68 is unfortunate. It doesn't square root. Does it simplify? Does anything go into 68 that's a square number?
4 and 17.
Hey, 4 and 17. 4 is going to work. So I'm going to show my work somewhere else. The square root of 68 is root 4 times root 17. So the answer is?
Root 2. 2 square root 17.
Yeah, 2 root 17. So now we have -10 plus or minus 2 root 17 all over 8. And then what can you do?
Divide.
You look at all the whole number components. The whole number components, not what's under the root, because what's under the root is its own thing. You can't mix square roots with whole numbers. But the 10, the 2, and the 8 are all divisible by 2. So you can divide all of them by 2. And we have -5 plus or minus. Do I have to write 1 root 17, or can I just write root 17? Do I have to put a 1 in front of the root 17, or just put root 17? You can just put root 17. We did it. Is that the same answer we would have gotten had we done completing the square? Yeah. Yeah, definitely. Provided you do both methods correctly, completing the square and the quadratic formula are telling you the same thing. They're telling you the 2 values of x that you can plug into the equation to make it true, and they're telling you the x-intercepts of your parabola. So which parabola are we looking at? The one that's below the x-axis with 2 solutions, the one that's on the x-axis with 1 solution, or the one that's above the x-axis with 2 imaginary solutions? Which one are we looking at? Which one for sure is it not?
Imaginary.
Yeah, it's definitely not imaginary because there's no I in there, so it's not floating above the axis. So are there 2 solutions or 1? There are 2. How do you know there are 2? Because of the plus or minus. You know, one of your solutions would be -5 plus root 17 all over 4, and then the other solution would be -5 minus root 17 all over 4. So that's definitely 2 different solutions. If you type those in your calculator, you'll get 2 totally different decimals. And therefore, this particular problem looks like this, with the parabola going down below the x-axis. All right. So how about number 24? Is number 24 written in standard form? Number 24 isn't in standard form at all. How is number 24 written? It looks like it's factored. Yeah, it looks like it's factored, doesn't it? Because I've got this 3x times x minus 3 equals 10. Could we, since it's already factored into 3x times x minus 3, could I just set both of those equal to 0? And solve that way?
You have to transfer 10 over, but
Yeah, would this be the correct solution, 0 and 3?
Because it's equal to 10.
Yeah, because it's equal to 10. What would happen if I plug in 0 right now? 3 times 0 is 0, 0 times all that is 0, I get 0 equals 10. That's certainly not true. And what would happen if I plug in 3 right now? I'd have 3 minus 3, which is 0. 0 times all that is 0. Again, I'd have 0 equals 10. So no, we can't just do that. And even if I bring over the 10, will it then be factored? Is this an addition problem or a multiplication problem? This is an addition problem because I have something plus or minus something. So this is not factored. Even though it looks factored, it's not really factored. In order to be factored, what does it have to be? It has to be just two things being multiplied and equal to 0. And that's not this. They wrote it in this form to trick you, to get you to start thinking, oh, it's factored, or oh, I'll just bring the 10 over and then I'll factor it. No, it's not factored. It's just written in a weird way. So what do we need to do to convert this thing into ax squared plus bx plus c? No. We'll have to distribute. So then we'd have 3x squared minus 9x equals 10. And then? Yeah, bring the 10 over. So we'd have to minus the 10 from both sides. And now it's 3x squared minus 9x minus 10. And now it's actually ready to do the quadratic formula. And so now we know a equals 3. What's b equal?
Oh, it's 3. Never mind. Sorry.
No problem, no problem. That was a good kid. What's b equal to? Yeah, negative 9. What's c equal to? Negative 10. All right, well, there we go. That'd be the problem. Everybody go ahead and do that one. And then we'll all compare answers at the end. These are the best chips on earth.
I know, I bought them for the kids and I end up eating them all the time.
I buy them for myself, and I eat them all the time. Nice.
Okay, what was it, 24?
Actually, the thing that showed everyone is a bit of a, I mean, it's correct, but it's also short. What I did was I said, you take each whole number part and divide them by 2. But I mean, if you allow them, there's a couple of lines that you can see you can't. The one end says I have greater than 10 plus or minus 2, 17, or 8. I could factor 2 out of the 10. So then I bring the 2 out of it. What is 17? Just to factor 2 out of the 2 in 10. Because now the 2 and the 8, I can simplify the rest. 2 doesn't do once, 2 doesn't. And what we see that we did here is that we did in fact divide 2 out of that, and that. The other way you can think about it is that I could multiply the top and bottom by 1/2. Because I'm allowed to do anything if I move the top and bottom. Because multiplying 1/2 and 1/2 is really multiplying. So now I can distribute 1/2 to that. And then again, we need after 10 is negative 5. After 2 is 1. And then after 3 is 4. Which way do you do that? What, just saying that you divide 2 into all of them? This one. Oh, no, this one. You took a 2 out of the whole numbers. Okay. Yeah, however you want to do it. All 3 of them are correct. Sorry, this is
Why did you do
my what?
17?
Oh, why doesn't the 2 come out of it? It just remains the same thing. Because the 2 is being multiplied by the 17. If you wanted to. Yeah. Okay, but still, good question. And had I changed this whole problem to negative 10 plus or minus 2x over 8, then you're definitely taking them in the direction, right? It's just x, it's just assumption. Yeah, the root is so much its own term, it's just a derivative. Okay. Good, good question. Did you work? Getting there? 3, 9, 10, good. How did it go?
Oh,
Oh, you're on some other problem.
yeah, the first one that we skipped, I was like, I'll just do that, and then not working, so.
Yeah. Which one? Oh, you just erased it all. Which one wasn't working?
Okay, I'll redo it, I'll get it right.
Yeah, I know you will, but maybe you didn't erase all that. The minus 60, which is negative 56. And what, you know that's not the right answer?
Yeah, because first of all, it says we cannot have our imaginary.
All solutions are real.
And if you look at the back, it says it's.
Well,
So,
gee, it'd make a lot more sense if it was 4 plus 60, because then that's 64, and square root of 64 is 8. So that would be nice. So I wanted to it's b squared minus, oh, it's minus 4ac. That's a minus.
I got 3.
I knew I did.
That was it. It was just a formula.
Yeah.
No, wait a minute. B squared minus 4ac. Wait a minute, what happened here? That's b squared. Oh, did you go in
That's a
and you
different problem.
rewrote it? Oh, okay, so you are putting the minus. Okay.
Yeah, but yeah,
I see.
yes, see.
I see. All right, let's compare, folks. We have negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I'll write it empty, negative b plus or minus the square root of b squared minus 4ac all over 2a. And then my numbers, okay, so b is negative 9, b is negative 9, a is 3, and c is negative 10. So I've got a chop, so that's 9 plus or minus the square root of 81, plus
120.
120. Yeah, 12 times 10. And then all over 6. And that gives us 9 plus or minus the square root of 201 over 6. Now, at first glance, you might say, okay, we're done. Is 201 divisible by anything?
Square root of 3 is 7.
It's just 3 and 67? Okay, so you can't simplify the root of 201. You'd have to sit there and try for a while. You'd have to check to see if it's... But yeah, if you just do the prime factorization, 3 times 67, and 67 is not divisible by anything, that's prime. So you're done. What does your parabola look like? Does it have, is it down below? Is it on, or is it above? How many answers are there? There's 2 answers, so it's below. So it definitely goes down below the axis because you have your 2 answers. Okay. So there's the 2 problems coming up, 25 and 26. I think we have time to do one of those. Which one would you folks like to see? 25 or 26? They look kind of the same, don't they? They sure do. They both are ax squared plus 7x. 25? I'm torn. I kind of want to do 26. What's the difference between 25 and 26? Which one did you do? Oh. And,
Just the end number is different.
yeah, just the end number is different, right? We have 8x squared plus 7x plus 4, and we have 8x squared plus 7x plus 8. Could that 4 and that 8 make a huge difference?
Oh, yeah.
What's going to be different about these 2 problems? Consider the quadratic formula. Negative b. Is b the same? Yeah. Plus or minus the square root of b squared, so that's 49, minus 4 times A times C. 4 times A is the same, that's 32, but one of them you're going to be multiplying by 4 and one of them multiplying by 8. So 4 times A is 32, and then it's either 32 times 4 or it's 32 times 8, all over 2A, which is 16. Well, I noticed right up front that if I do 32 times 4 is pretty big. It's like 144. No, 100 what? 128. And 49 minus 128 is negative, which means this answer is imaginary, right? Well, what if I had done 8 instead of 4? Then that's even bigger, and 49 minus 256 is still negative. So are both of these going to be imaginary? Yeah, both of them are actually going to be imaginary. And there's not that big of a difference between these two problems. Is there? I suppose the only difference might be whether or not you can actually simplify it without a root, or no, there's going to be a root because there's going to be an I. Okay, well, all that said, which one should we do?
You just did both of them, so maybe we should do the next page.
Well, we didn't actually finish either of them.
Yeah, we just didn't do the arithmetic.
We just didn't do the arithmetic. Yeah.
I mean,
So
that's too much.
that is, I mean, yeah, that is it. So let's do 26. So for 26, the first thing we have to do is write it in standard form. So that means we have to bring the 7x over, bring the 8 over, so we have 8x squared plus 7x plus 8. And then we can identify our numbers as 8, 7, and 8. By the way, have you folks noticed that we haven't even thought to factor anything? Normally when we look at a quadratic like this, we try to factor things, right? Multiply the first number times the last number, make a factor table, 1 to 2 numbers multiply to make the last number, the add to make the middle number. Why aren't we even trying to do that right now?
I don't really save all that much time.
No? Well, what if most of our answers turned out to be fractions and roots? Do you factor things into fractions and roots? Normally we'd factor it and the answer is a whole number. So you see, these are problems that can't be factored anyway. These problems can't be factored anyway. If you had tried to say what multiplies to make the last number that adds to make the middle number, you would have had no answer. You would have said, oh darn, I can't find 2 numbers that multiply to make the last number that add to make the middle number. So we would have just been stuck. Okay, so let's do this last one. So negative b, I'm not going to write, well, I'm just going to write it empty this time. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b plus or minus b squared minus 4ac all over 2a. You said it was what, Alex? 256?
Yeah.
Which is negative 207? And is 207 simplifiable? I think it's divisible by 9.
9.
Yeah, so that's 207 is really 9 times something. What is it? 23? Yeah, so that simplifies down into root 9 root 23, which is 3 root 23. So it's simplified a little bit. Negative 7 plus or minus 3 root 23 over 16. Is there anything else we can do to that? What, Olivia? Oh, there's no. Oh, that was negative. So sorry. Yeah, that was a negative in there. So I should have put an I out front. So that was actually 3i. Thank you, Olivia. So what does that parabola look like? Since it's imaginary, where's the parabola? We either say it's below, on, or above. Above. That problem would be above because it's imaginary. They said what, Olivia?
They sent to I square root 207.
Oh, did they really?
Yeah, they didn't even simplify it.
Those slackers. They didn't even simplify it. They
Uh-uh.
said -7 plus or minus I root 207 over
That's
60.
all they did.
Yeah.
They were slacking.
Slacking. Folks, what part of the quadratic formula determines whether or not the solution will be imaginary or real? The what?
The, what goes next to -4? So the A and the C.
What determines if the solution is imaginary or real?
First term and the last term.
So imaginary means that you're square rooting a negative. And real means you're square rooting a positive. What if you square root a 0? What if that whole thing turned out to be a 0? The square root of 0 would be 0. And plus, you'll note, what does plus or minus 0 do? If you had like
It does nothing.
5 plus or minus 0 all over 2, your two possibilities would be 5 plus 0 over 2 or 5 minus 0 over 2, which would be 5 halves or 5 halves. What does that mean? I got the same answer twice.
So there's one,
Means there's just one solution,
X-intercept.
and there's only one x-intercept, which means what's the parabola doing?
Linear equation.
What is the parabola doing if it's just one solution? It just sits on it, right? It's just barely touching it. So this is interesting. We've experienced enough now about the quadratic formula that we know that if b squared minus 4ac is negative, that means it's imaginary, which means the parabola is above. Whereas if b squared minus 4ac is a positive number, then you can square root it, and you're plusing or minusing a number that gives you two different solutions, which means it's below. Whereas if b squared minus 4ac is 0, then that means there's really only one number that's a solution, and that means you know it's on. So this b squared minus 4ac term is actually really important because it's telling you whether or not the parabola is below, above, or on. And it's telling you the nature of the formula. So that's what I'd like us to go ahead and take notes about right now. We're gonna draw it out and really understand what that term underneath the square root is telling us. So notice the notes up at the top. It says, use the discriminant to determine whether the solutions for the equation are two rational numbers, one rational number, two irrational numbers, or two non-real complex numbers. Also, can it be factored? Okay, well that's a lot. It's a lot to think about. So let's start at the beginning here, folks. When you look at the formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. I want you to circle the b squared minus 4ac part and call that the discriminant. It's not the square root of b squared minus 4ac, which is the discriminant. It's just b squared minus 4ac. That's the discriminant. Now you might be saying discriminant. What a funny word. Do we use the word discriminant for anything? I don't think we ever use the word discriminant. Do we ever use the word discriminate? I mean, discriminate, on the one hand, is a terrible thing, right? It's when you discriminate against other people based upon race or religion or skin or sexuality or something like that. That's discriminating in a bad way. Do we ever use the word discriminating in a good way?
Discriminating taste.
Exactly, discriminating taste. I have discriminating taste when it comes to chocolate cake. I can tell you which is the best chocolate cake and which chocolate cake is no good at all. And there we talk about a discriminating taste. You know, I'm not somebody who's just going to eat any old chocolate cake. I'm not going to waste my time. Only the best of the best chocolate cakes. Have you guys heard the word discriminate in that context? Yeah, discriminating taste. So the word the word discriminant here is referring to the way that you discriminate between different choices, much like you discriminate between good cake and bad cake. So discriminant means we're discriminating between different possibilities. So let's go in a nice little order here. We're going to consider first, what if b squared minus 4ac is less than 0? That's case 1. If you want to write it out ahead of time, we're going to do b squared minus 4ac is less than 0. We're going to do b squared minus 4ac is equal to 0. And we're going to do b squared minus 4ac is greater than 0. Because these are the three possibilities. B squared minus 4ac can either be a negative number, 0, or a positive number. So let's follow the chain of reasoning here. If b squared minus 4ac is less than 0, what does that mean we're square rooting? We're square rooting a negative number. Right? If b squared minus 4ac is less than 0, we're square rooting a negative number, which means what?
Yeah.
It means there's an I in there somewhere, which means there are two imaginary solutions. And what does that look like? The parabola is above the x-axis. Is that a fair chain of reasoning? You can walk yourself through that. You can say, well, if b squared minus 4ac is less than 0, that means I'm square rooting a negative number. That means there's going to be an I. That means there are two imaginary solutions. And that means the parabola is not even touching the x-axis, it's above it. All right, what's the chain of reasoning for b squared minus 4ac equaling 0? What does that mean we're square rooting? We're square rooting 0. And what does that mean if you square root 0? That means you'd have some sort of, I'm going to write example, such as 5 plus or minus 0 over 2. Well, that means that you'd have 5 plus 0 over 2, which is just 5 halves. Or you'd have 5 minus 0 over 2, which is still 5 halves. Which means, what? Yes, correct. There's just one solution. One real solution. Real, notice. You cannot have one imaginary solution. Because if there's a negative number inside, that means there's an I, and more importantly, what's out front? What's out in front of the square root? The plus or minus, which means it's a plus or minus. That means definitely two imaginary solutions. It's only the fact that it's 0 that there's only one solution. It has to be real. And so what does that tell you about your parabola? It's on the x-axis. So what's the last chain of reasoning? If b squared minus 4ac is greater than 0, what are we square rooting? A positive number. And if we're square rooting a positive number, that means we can actually square root it. It's a real number, it's a decimal. And that means, in an example like 5 plus or minus root 3 over 2, that means we genuinely have two different solutions, 5 plus root 3 over 2 and 5 minus root 3 over 2. It's going to be two different solutions. Two real solutions. And so what does our graph look like? Yeah, that means we'll have two x-intercepts And that means that your parabola is where? What word should we use? Above, on, or below. What is above, on, or below? The parabola? What is above it, on it, or below it? What point is above, below, or on? The vertex. You know, what we're really saying here is that the vertex is above the x-axis. So is the whole parabola, but the vertex is. And what's on it? The vertex is on the x-axis. Whereas here, the vertex is below. So we could say the parabola is above, on, or below, but it's even more specific to say the vertex of the parabola is above, on, or below. Okay, so we use the word discriminant to refer to b squared minus 4ac. That's the discriminant, because it discriminates between these three choices. So let's see here. There's one other possibility, which is pretty fun, and I'd like to point it out to everybody. We'll see it as we go along. Because I think we all kind of ran out of room taking notes up there, right? There's no more space. All right, so what do we need to do? It says use the discriminant to determine whether the solutions for the equation are two rational numbers, one rational number, two irrational numbers, or two non-real complex numbers. And also, as a bonus, can the original formula be factored? So this is what we're going to do. We're not going to solve the whole thing. We're just going to calculate the discriminant. So for number 27, A is 1, B is -6, and C is 5. Right? And we're just interested in the nature of the solution. We don't actually have to solve for the values of x or x. We're just curious, what is the nature of this parabola? Is it above it, is it on it, or below it? So we'll just calculate b squared minus 4ac. Isn't that nice? A savings. We don't have to do the whole thing, just b squared minus 4ac. And again, I would write it empty, b squared minus 4ac. And so that's -6, 1, and 5. You know what's mathematically and philosophically very pleasing about this? B squared minus 4ac uses each of the three letters once. Right? Who is responsible for determining the nature of the parabola? Is it A alone, B alone, C alone? All three of them together. A, B, and C are all three required to tell you the nature of a parabola. It's not enough just to know B or C. You have to know all three of them and how they interact with each other. So what do we have here? 36 minus 20, which is 16. So what does that tell us? 16 is positive. So there we go, 16 is positive. And so immediately we know that we have two real solutions, and the parabola looks something like this. All right, there's one more thing though about this. What do you notice about the number 16? You recognize the number 16, it's your friend, it's 4 squared. It's square rootable. The number 16 is square rootable. This is a big deal. Because of the fact that 16 is square rootable, that means that this can be factored. Does that make sense as to why that would be true? Because 16 is square rootable, I can look back at this and immediately say, oh, well, that means I should be able to factor this. And in fact, what is the factoring? What numbers multiply to make 5 that add to make -6?
-1.
Yeah, 5 is really 1 times 5, but I want them to add to -6, so they're both negative. And sure enough, it's s minus 1, s minus 5. So when you do the discriminant, and the discriminant is square rootable, that tells you that the original can be factored. It's kind of like a quick check. Like, should I just factor this, or do I need to go do the quadratic formula or complete the square? It's a real quick check to give you confidence whether or not something can be factored. That's really cool. It's a factor test. The discriminant is a factor test to tell you whether or not you can even factor that thing and whether or not you should bother. Isn't that cool? Yeah, that's really cool. That's really cool. So for instance, right here, t squared minus 2t plus 1, is that factorable? Let's do the factor test. B squared minus 4ac. So we know that a is 1, b is negative 2, and c is 1. So that'd be b squared minus 4ac. b is negative 2, a is 1, c is 1. That's 2 squared is 4 minus 4, which is 0. Is 0 a square number? What times what equals 0? 0. 0 is a square number. Remember, if you look at all the counting numbers, 0, 1, 2, 3, the square numbers are 0, 1, 4, 9, 9, 16. 0 is a square number. Right? So if b squared minus 4ac is a square number, that automatically tells you that you can factor this thing. And of course, we probably already knew that. Maybe you already guessed that it was t minus 1 times t minus 1. So it was factorable. What else do we know about this parabola? What does it look like? Yeah, there's one real solution, and it's sitting on the x-axis.
Could you call it the vertex?
Yeah, the vertex is sitting on the x-axis. Yep. Isn't that fun? So, what, 27, 28? So that's what we're doing right here. That's what you're doing for the next couple problems. You're just calculating the discriminant, and that's going to tell you what type of solution it is, and if it happens to be a positive number that's a square number, that tells you that it's factorable. So everyone go and do 29 and 30. And determine everything about the solution. Determine if it's above, on, or below, and determine if it's factorable.
Oh, because you have a little drop down. Oh, that's what it is. Right.
I have the worst handwriting ever.
Well, I don't think it's bad handwriting.
And honestly, I blame like my 6th grade teacher because he told me if I didn't fix it, it would be that way forever. And I think just to be spiteful, I never did. So
Well,
I just,
well, okay, well, I see what you did.
yeah.
Oh, that's a little bit expensive.
Yeah, we should just all blame our 6th grade teachers for everything.
No, that's a true story.
Oh yeah, I blame my
believe
6th
you.
grade
Yeah, I
teachers.
had one brown eye and one blue eye.
I have one purple eye and one gray eye. Oh, the 6th grade teachers. Huh?
I have to copy on the list.
I went to school to do go too.
Who's Iowa?
Walking around the room, I think a lot of you, for number 29, did you get 57?
Yeah.
Oh,
You did 49 minus.
There you go.
Is that the final answer? You just leave it like that?
What, 57? Your final answer, the question was to discriminate between the type of solution. So the numerical answer is 57, but the actual answer is that since that number 57 is a positive number, that tells you the quadratic is going to be below the axis, having two real answers. So 2 real answers. And then you would say not factorable, because 57 is not a square number. So 57 is simply the test value that you're looking at. The answer is a picture of a graph and a statement of how many answers there are in what type. Yeah, thank you, Jeff. That's a good question. No, when it's positive, here, when it's positive, there are two answers. And if it's positive and a square number, then it's factorable. So this last one has two scenarios. If it's positive and it's a square number, it's factorable. If it's positive and it's not a square number, it's not factorable. So you can say a positive square is factorable, whereas a positive non-square is non-factorable. Amy, does that answer your question?
Yeah.
Okay, yeah. The last case of a positive number has two scenarios. A positive square number is factorable, and a positive non-square number is non-factorable. And how about the last one? B squared minus 4AC. Did you all get -3?
Yes.
Yeah. So -3 means it's imaginary, it's floating above, and it's two imaginary answers.
Not factorable.
What?
Not factorable.
And yeah, definitely not factorable, right? You know, folks, to be fair, I kind of ignored this scenario with the 0. If it's 0, is it factorable? It's actually factorable if it's 0 as well. Oh, no, I didn't ignore it. I said so. Because 0 is a square number. So it's actually, shoot, it's a positive, if it's a positive square number or 0, 0 is always factorable. Yeah, so it's factorable if it's any square number. That includes 0. All right. Folks, you know a lot about quadratic equations now. A lot. You know how to factor a quadratic equation. You know how to do completing the square. You know how to do the quadratic formula. You know how to read the discriminant. You are quadratic formula experts. Who didn't get a copy of the Midway quiz? I think yesterday I gave it out, or Tuesday I passed that. Who didn't get one? Amy, did you get one? Oh, did you get one, Amy? No? Everyone here got one? Oh, okay, well, great. Did anyone want another one? Because I have extras. All right, Claudia, yeah, why not? Everybody else want an extra? All right.
It's due on Monday, right?
Yeah, it's due on Tuesday.
Yeah.
So, folks, you know that next week we're all going to be very sad.
Because we only have math class twice.
No, because we only have math class once. Yeah, we don't
get to
have.
come on Thanksgiving.
We're not here on Thanksgiving.
That sounds like an amazing excuse to get out of Thanksgiving.
Yeah, I know, right? Yeah, sorry, I have to go to class. I don't want to get out of Thanksgiving though.
That's good. I'm glad you
want
like your family.
I didn't say that. I just want the food, but I do like my family as well. But the food is amazing.
It's like 5 in the afternoon. I'm like, what?
All right. Well, folks,
You didn't tell us a joke today.
I didn't?
No.
Okay, I have a joke for you all. Knock, knock.
Who's there?
Everybody needs to say it. Knock, knock.
Who's there?
Interrupting cow. Moo. Yeah, you guys, no one actually started saying interrupting cow.
I did.
Let's try it again. Knock, knock.
Who's there?
Interrupting cow.
Interrupting cow.
Moo. There. I have another good one that you guys will all really like. Why did the chicken cross the road?
I don't know why.
To get to your house. Knock, knock.
Interrupting cow.
The chicken!
Oh.
I think that was really clever. Very clever. Okay, so your midway quiz, that's due next Tuesday, but I think we could go ahead and we have a couple minutes. I'm going to give you a choice. It's 3:08. We have 12 minutes. Either I will give you, either we can start looking at section 10.4, or I will offer you another extra credit opportunity worth 5 points if you take notes on a problem I'm about to do up on the board, and then write it again in your own handwriting and turn it in next week. It's one problem. One problem that if you all solve it with me, go home, write it again in your own handwriting, turn it in, you get 5 points extra.
Or what's the other option?
Starting with 10.4. You don't want extra credit?
We do.
I
I actually would kind of prefer to do this problem because it'll impress all of you so much. And because, honestly, we deserve a break before we move on to new information.
Yeah, and those other people should have come to class.
Yeah.
Or watch the video.
So here's what we're going to do, folks. This is for extra credit, so go ahead and label a sheet of paper. Extra credit, 5 points. This is going to change your life.
Should we put our name on it?
Yeah, put your name on it.
I like you said that you're
Sorry.
like you have to be every
Thursday.
Okay, we're going to have to do this all within 10 minutes. So write quickly. All right? So the extra credit is to go back in time to the year 1500 and solve the quadratic equation for the first time. So this is ax squared plus bx plus c, and we're wondering what is the solution in general? Without any numbers. No numbers. We're just going to solve it using completing the square. And then when we're done, we should be able to say x equals something, and it will be the answer in terms of a, b, and c. And what we're going to do is just complete the square. So remember the steps for completing the square. We're going to move c over, we're going to divide the a off of everything, we're going to take half of the middle term, square it, add that to both sides, rewrite this as a perfect square binomial, and then square root both sides and move that over and we'd be done, right? So we're going to do that whole process that we did at the start of class. So let's go ahead and start. Everybody, move c over to the right and leave space. A, x squared plus bx, space, negative c. We're doing completing the square, just like we've done, but we're using letters instead of numbers. What'd you say, Libby? Yeah, we're using letters instead of numbers. But we're still just doing the same process, So what have we done so far? We moved c to the right. Now what do? We have to make this x squared, not ax squared. So we're going to divide everything by a. So we divide everything by a because we want x squared to be by itself. Okay, what's the next part? What's the classic thing that we do? We take the middle term and divide it by 2. So what's 1/2 of b over a? What's half of b over a? b over 2a, right? Isn't that half of b over a? Is everyone in agreement? That half of b over a is really just b over 2a? Okay, so you take half of the middle term and then you square it. And that gives us b squared over 2 times 2 is 4, a times a is a squared. So we took the middle term, divided it by 2, and we squared it. And so what are we going to add to both sides? b squared over 4a squared. So I'm going to add b squared over 4a squared to both sides. Okay. What was the next step? We rewrite the left-hand side and we add the right-hand side, right? So how do we rewrite this now as a perfect square binomial? Yeah, it's x plus b over 2a, because b over 2a was the number that we were squaring. And then what about that other side? Whew, we have to add those together. How do you add negative c, now you're going to have to show work for this. How do you add negative c over a plus b squared over 4a squared? Do they have a common denominator? Not yet, but what would the common denominator be? 4a squared. So what do I have to multiply this one, top and bottom? 4a. So now I have 4a top and bottom. And I'm going to rewrite that now. That's negative 4ac all over 4a squared plus b squared over 4a squared. Now just for fun, if I'm going to add two fractions together, we could write it as negative 4ac plus b squared all over 4a squared. But I would rather not have my first term be negative. So instead I'm going to switch the order of those two terms, and I'm going to write what?
B squared.
B squared minus 4ac all over 4a squared. And that is the sum of those two fractions. So you see how I kind of had to move off over here, do a whole lot of work, and then come back. And now my answer is b squared minus 4ac all over 4a squared. All that work is necessary for you to show me if you want your full credit. Because that was a whole lot of work that we just did to add two fractions together. All right, well, we rewrote everything. Now what do we do? Square root both sides. On the left-hand side, that's nice and simple because it's just x plus b over 2a. What about on the right-hand side? How do you square root a fraction? How do you square root a fraction?
You do the square root on the top and the square root on the
Yeah,
bottom.
you do the square root of the top, which is the square root of b squared minus 4ac. And you do the square root of the bottom. What's the square root of 4a squared?
2a.
Are you sure? What's the square root of 4a squared? That's the square root of 4 times the square root of a squared. The square root of 4 is 2. And what happens when you square root a square?
A.
They cancel and you get a. So yeah, it was definitely 2a. Just wanted to make sure everyone believed it. All right. Oh, and by the way, that was a square root, so that's a plus or minus. And now what? X is being added by b over 2a. So you subtract b over 2a from both sides. And we get x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And then what can we do with our final answer?
Combine like terms.
Kind of combine like terms. What do you mean by that? We have a common denominator.
Right, so negative b plus or minus the square root of b squared minus 4ac over 2a.
Yay!
I guess that's
Huge smiley face.
that is the quadratic.
Yeah, isn't that cool? Where did the quadratic equation come from? The quadratic formula. Where did the quadratic formula come from? What method?
Square.
Completing the square. The quadratic formula is completing the square. It means somebody completed the square on the original ax squared plus bx plus c so that no one else would ever have to. They completed the square once and for all. And they said, this is the result of completing the square on ax squared plus bx plus c. And that's why, for the rest of us, all we have to do is just drop in the values for a, b, and c, and the quadratic formula calculates it for you. It was that cool or what?
Mm-hmm.
It's pretty cool. It's pretty amazing to see where the formula comes from. You have all now derived the quadratic formula. That is an elective club to say that you have derived the quadratic formula. Okay, so you can't turn that piece of paper into me. You get to do it again. You do it again. You make it nice and clean. You write your name up at the top. my derivation of the quadratic formula. You show all the work and you bring it in, and I'll give you extra credit. That's not a bad idea there. Are you taking a picture? Yeah, go for it. You can take a picture. All right, well, very nice, folks. We accomplished a lot today. Oh, sorry.
That's okay.
Yeah, if any of you want to take a picture of the board, that's totally fine. Now you know what you can do next year for Halloween.
Go as the quadratic.
You can go as a derivation of the quadratic formula. You know, wear an outfit that has that whole thing on it.
To the math party?
Yeah, to the math part. That would be super cool. Let's see, yeah, and then we'll do 10-4, 10-5, 10-6. Oh yeah, we're doing great. What is today, November 16th?
Yeah.
Oh darn, oops, we were supposed to also get through 10-4.
Yeah.
Well, that's all right, we'll do it next time. We still have plenty of time. We still have 2 more whole class periods before we do the review. I gave us a whole class period just for 10-8. We didn't need that. No, we did great. Today was really good work, folks. We really did cover a lot, from completing the square to the quadratic formula. These are challenging concepts. All right, well, class is over, isn't it?